Greetings to all my tech heads out there in the KevTechify nation, and if you're new here, welcome. In this episode, we're going to look at the types of IPv4 addresses. We'll be discussing public and private IPv4 addresses, routing to the internet, special use IPv4 addresses, loopback addresses, linked local addresses, legacy classful addressing, and finally, assignment of IP addresses. This episode is part of my series on Introduction to Networks for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. There are certain types of IPv4 addresses that are used in different cases. One of these is the idea of public and private IP addresses. A private IP address was established back in the early 1980s, with RFC 1918. And what this did was allow companies to use these IP address ranges. And as you can see, we have three of them here. We have the 10. network, we have the 172.16 network, and we have the 192.168 network. Anybody can use these. Multiple people can use them. And these are the only private IP addresses you can have. They stay within your company, within your network. A public address is routable on the internet. That's what websites use. That's what anything on the internet uses, a public IP address. How routing works on the internet is with these public and private IP addresses. We have our companies, and let's say each one of these clouds here on the left side, that represents a company. This company, they can use any of these private IP addresses in there, and they can set up, they can connect all their devices up. They can have thousands of devices, computers, users, printers, scanners, voice over IP phones, all hooked up in that type of stuff, and up and working with any one of these private IP addresses. We got a 10. number here, we got the 172.16, and we have 192.168 over here. All working good in the company, but as soon as any of those private IP addresses make it to a router that's connected to the internet, and so right here they come up to the ISP, and then the ISP is connected to the internet. This router, the ISP router, is going to say, hey, this is a private IP address. We don't route these on the internet. We're just going to drop the packet. And another word for dropping the packet is deleting the packet. And that's how we can use these IP addresses on our networks. Private IP addresses, anybody can use them. I can set up a network that uses the 10. network. You can set up a network that uses the 10. addresses also. And we could have the exact same 10. addresses on my devices and on your devices, but because they're private, because the devices on the internet don't forward those packets on, they get deleted. This allows me, you, anybody else to use that exact same network internally. That's what we call, these are private addresses. They are not globally routable. We have two more special use IPv4 addresses. One is the loopback address. What the loopback address is basically talking to yourself. Some days nobody else is listening. You want to talk to somebody, you talk to yourself. If you're lucky, you answer yourself. And that's what happens here. This is a special address. First octet is 127, and then you can fill it in. Most people use 127.0.0.1 is the loopback address, but technically it can be any address in this range here. And what we do is when you want to communicate with yourself, when you want to test what's going on with yourself, we use that. One example would be you have a web server on the same box as your SQL database. And a lot of times you have to put a IP address in on that web server to connect into your database. Now, instead of using the IP address that's assigned to the interface what we can do is just put our loopback address in there, and basically I'm going to talk to myself, that computer is going to talk to itself and contact the database. Another example where we use this is pinging. And so right here from our command prompt, we ping 127.0.0.1. What that does is it pings my interface, and it shows me a couple things inside of Windows. It shows me that my TCP/IP stack is installed correctly and operating. It shows I have layer 1 connectivity. I have a physical wire plugged into my network port. It's turned on, and the other end of that port is plugged into another device that has an active port there also. And so this is one of my first steps in troubleshooting, is ping my loopback to make sure I have that working. The other special use address is what we call a local link address. And this is something Windows uses. A lot of times your computers are set up to pull an IP address automatically from a DHCP server. You turn it on, it gets an IP address from the server, you connect to the network, you're good to go at that point in time. But if you're set up to obtain that IP address automatically and there's no DHCP server, after a while, it's going to air out. And on Windows, when it airs out, it gives you a 169.254 address right here. And now, I guess I shouldn't say it's Windows. It's a lot of networking devices. And it gives you an IP address here. Now, this IP address, it's usable for if you had a small office, like a veterinary office where you got 2 or 3 computers, you could use this at this point. This address is called the APIPA address, APIPA, Automatic Private IP Addressing. And it's a protocol set up that if there's no DHCP server, you can get an IP address and you can still communicate on your network. I hope you're liking this episode on types of IPv4 addresses. If you have the time, please leave a comment and let me know what you think about the different types of IPv4 addresses. You can also visit my website at KevTechify.com for all of my details and how to get all these episodes in video and podcast form. Way back in 1981, an RFC was put forward, RFC 790, to break IPv4 addresses into classes. What this classes represent is the number of hosts and networks in a range here. And what it did is it broke these addresses down. In a Class A address right here, if you look at the first octet, has a range from 0 to 127. Now remember, 127 is your loopback, so technically it goes to 126, but this is a Class A address. A Class A address, if you look over here, there's a total of 128 of those networks. But each one of those networks have 16 million hosts per network. This is for a big company. This is for a company that has millions of users and devices. And there's really only a handful of companies in the world that are that big right now. US government, HP has one, 3M I believe has one also. Then we have a Class B address. And if you notice, Class A, the subnet mask here was a /8. For a Class B network, we are now to a /16 address. The first 2 octets are now network portion. And with a Class B address, if we come over here to our little chart, there's 16,000 networks. Each one of those 16,000 networks has 65,000 devices or usable IP addresses in there. Class C address goes from 192 to 223. It is a /24, so our first 3 octets are now the network portion, leaving just one octet for the host. Over here on a little chart, that means there are 2 million Class C networks. Each one of those 2 million Class C networks, they can have up to 254 devices on that network. This would be for a small company at this point in time. Then we have a Class D and Class E. Class D Goes from 224 to 239. This is your multicast communications. And class E is for experimental. I have never really heard of anybody using this, but it is there. I'm sure they're using it somewhere in the labs. Now, this is what we used when we had classful routing. And what we mean by classful routing or classful addressing is it was broken up on the octets. Class A, it was between the first and second one. Class B was a /16, so the network host portion was between the first 2 octets and the last 2 octets. And Class C address was a /24. That means it was the first 3 octets were the network portion, the last octet was the host portion. This was very wasteful. Companies would get a Class A address and maybe only have 1,000 workers. Maybe they're only using 2,000 devices, but a Class A address had 16 million. And so there was over 16 million unused IP addresses. It was very, very wasteful, this classful addressing. Eventually, we got rid of classful addressing, and what we did is use classless addressing. Classless addressing is where instead of having a /8, /16, /24, we can have a /25, /26. That networking portion doesn't have to follow the octets anymore. And that helps us make better, more efficient use of our IP addresses. Now, handing out the IP addresses. The overall global authority to hand out IP addresses, IANA, the Internet Assigned Numbers Authority. They are responsible for handing out IP version 4, IP version 6 addresses. What IANA does is hand out IP version 4 and IP version 6 addresses to regional internet registries. The regional internet registries then hand out IP addresses to IPs or major ISPs. Then they hand it out to their users. And so this whole process of getting IP addresses starts at a global level, then it goes down to a regional level, kind of like by continent. And then each one of those continents, they hand out IP addresses to their internet service providers. Then they hand it out to either smaller internet service providers or to their clients at that point in time. It was my pleasure to bring you this wonderful episode on the types of IPv4 addresses. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. In the upper right is my playlist for my series on Introduction to Networks for the CCNA. In the bottom right is one of my favorite videos that I picked just for you. Thank you so much for watching this episode of my series on Introduction to Networks for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.